Hey everybody, sorry for the delay here. I'm just trying to get my fancy OBS tool to work properly. So, not sure. Are you guys seeing my picture or are you guys seeing the slides? Thanks, Matt. You guys seeing the slides or my picture? Oh, perfect. Okay. Well, good. Let's get started then. I don't know why I keep seeing my picture, but appreciate everybody joining today. All right. Perfect. All right. So just wanted to thank again our sponsors here. So let's go ahead and get started. So our two sponsors are Deliveron and Dynamo. So if you're not familiar with Deliveron, we are a leading managed service provider and consulting firm focused on helping organizations advance their digital transformation goals by modernizing business applications, migrating solutions to the cloud, and applying agile and DevOps engineering practices to build new innovations solutions. Our other sponsor, Dynamo, they're a trusted partner. If you're an organization looking for high quality technical individuals, also if you're looking to make your next move in the technical force, Dynamo is a great place to look there. So, once again, thank you, Deliveron and Dynamo, for sponsoring today's event. Really excited to kind of get this back on the board and start doing these more often. So, just a few announcements before we begin. The first one here is, as you're all on, is this is our new Omaha DevOps Meetup YouTube channel. So hopefully from here on out, and both virtual and in-person meetings, when we can get back to those, will hopefully be saved up here so we can view them for a future time. The other question had, based on the number of people, looks like this worked pretty well, but I really wasn't sure with everybody home right now, would 6 o'clock, kind of our normal time, or 4 o'clock be better? So I'd just be curious if you guys could, put in the comments there in the chat if one of those two times are better for you. But I thought with this here, 4 o'clock probably be good. All right, I see some good 4 o'clock comments on that there. So next, we're looking at doing a virtual open spaces session in April. So probably look at using something like Zoom or Teams to be more collaborative here. So it's not just one direction there. It'd be kind of hard to do open spaces with just one person talking. Great. Looks like it's almost unanimous at 4 p.m. Except for probably all the 6 o'clock people that can't make this time. Also looking to need more speakers. So, I've been been one of the organizers of this group here for a little over a year, and this is my first time speaking at it, so I'm excited. But we definitely need more speakers. So if you're interested, please reach out to me on the meetup and there. So, without further ado, let's go to our feature presentation. So today we're going to talk about building a secure CI/CD pipeline. And my name is Mike Douglas. If you don't know me, solution consultant for Deliveron. And if you don't know me, my passion really is about helping organizations and individuals really improve their DevOps practices. So whether that's automated builds, deployments, testing, and security, like in this talk, this is what I really enjoy doing. Really enjoy helping teams basically improve their processes to speed them up. So this is a talk I've done a few times, and one's been pretty exciting to figure out. So really excited to show you guys here some of the things that we've been doing around security. All right, so why is security so important? And one of the big reasons that security is so important, I'd say probably in the first 15 years of my career, security was really hardly ever talked about. And why is that? Well, from a developer perspective, we've always kind of thought it was an ops problem. I'd say very rarely we knew about security, but we really didn't do anything. It was like this whole other thing, and we always can kind of just throw it over the fence and say, "Oh, the ops has that," or security team or network team can really do that. On the other side, from an infrastructure standpoint, is they really looked at security as a perimeter defense. And the challenge with that is what happens if somebody gets through that perimeter. And we'll talk about this in a little bit about assume breach. So that once you get past that perimeter, if you just kind of harden up that, it's wide open. So and any other things where it just has a tough perimeter and nothing behind it, what happens if it breaks? Just like an egg, it will crack. So those are some, I'd say, historical challenges. Probably the biggest change today is that security is really everyone's job now. And so what are some of those challenges, like you mentioned? Well, the first one, probably why I didn't hear too much about security the first 15 years, is because most of our applications we're building were behind corporate firewalls. And that's not the case anymore. We have a lot of applications that are being built in both publicly exposed and out in the public cloud. So that definitely opens up some challenges. The other thing is data breaches are being happening in the news on a weekly or monthly basis. There's hundreds of companies, billions of accounts that have been hacked. Almost a lot of names everybody's heard of, and I'm sure nobody wants their company to be named next. So that's a huge driver on this, and why it's when we're building applications, security is one of the first things that are discussed. The other thing is there's this movement, obviously building applications, trying to go faster. So first Agile, now DevOps, trying to, deploy up to 10 times a day. Traditional practices are where the security team would, review things before it goes into production. If it takes 2 weeks, we can't deploy once a week to do that. So that's why we really need to have those practices and shift left, and that's really about what this talk is here. And then the other challenge is modern applications. There's a lot of applications today, or I would say even more complex than they were. Things where they need to work across different platforms like mobile phones. There's SPA-based architectures. They're publicly exposed to the internet. They have backend APIs. So there's a lot of challenges to why applications today are harder to secure. So all those challenges today are really what we're talking about. So when we talk about what makes an application secure, we really look at it as 4 things. The first one is the infrastructure, and that's really where it starts, is having that secure infrastructure, having the application built with a secure application architecture, the continuous validation, and that's where we're really taught primarily in this today. And then the last one is being able to monitor the application once it's already in production. So we'll touch on the other 3 here real quick, but we're going to spend most of the time talking about this continuous validation. So before we can start building an application, we need to have that secure physical security controls in place. So what I always like to say is, we may be building the most secure application in the world, but if it's on my laptop in my basement, all somebody has to do is walk in to get it. So we really need to make sure those security controls are in place, and I'd say probably almost all places today have those. Obviously, the public clouds do, and most data centers do too. From an infrastructure standpoint, also too, is making sure that we're doing things from a security standpoint around data. So making sure that data is encrypted through things like TDE. But then also when we're actually have data in transit, making sure we're using things like TLS and SSL to secure all of our data that's being transported. One thing to note though here is that you really need to make sure you're using the right versions of this, because it's not all the same. Most organizations are trying to only support TLS 1.2 or higher, and so previous versions have some security vulnerabilities, so you want to make sure that is the case. And then also there's tools like this SSL Labs that you can actually go out and test your certs on them and see how they rate. In this case, this was actually a real one that we did a couple of years ago, and everything from our side you can see is green, but we still received an F. It turns out that same cert is actually being used on another server that had a vulnerability. So that's why we got the overall grade of an F. We had that other server. It was like an ADFS server or something like that, and they updated, they got theirs fixed, and then we reran it and got the A. So tools like this are even know beyond just your single server there. So really important to have. The other thing, a couple other things from an infrastructure standpoint is many applications today really one of the things you want to be able to protect it from is distributed denial of service attacks. And what that means is, if basically malicious requests are coming in at a high rate, they're going to basically block in your good users and actually take down your web servers. I'm sure many of you are familiar with some of those attacks that have happened over the years. But there are different services that you can use to actually protect from that, and it'll actually redirect those bad calls away from your website and only allow the good ones in. The other thing that we're using on a number of our applications is called the Web Application Firewall. And what the Web Application Firewall will do is actually inspect every request coming in, and you can set it to either just detect malicious requests or actually deny those and prevent them from going through. And they reject things like the OWASP top 10. So they'll prevent things like injection, cross-site scripting, and those types of things. So it'll actually protect you there. So those have been really popular. We've actually used those on about every application that we've built here that's public facing, and it just definitely helps from a security standpoint. All right, so once we have that secure infrastructure in place, the next thing that we want to make sure is that our applications are being built in a secure way. So one of the real pieces there is when we build an application is we talk about security in a layered way. And this is really important because think about the layered security as doors, and each of those doors have a lock. And what we don't want to do is we don't want to lock all of our doors with the same key, because then it doesn't really matter how many doors we have, because if somebody gets through the first one, they can basically go all the way down to the data, which is the most important piece to protect. So what we want to do is actually use different kinds of keys on those different layers. So if somebody gets through one layer, they're basically blocked before they can go to the next one. So when you look at something like this, you can see our front door is our basically our identity, and making sure that identity protects things like authenticated users. We want to always be using HTTPS. We want to have things like the Web Application Firewall in place. One of our applications we built, we actually knew where the customers were coming from, and then we would actually be able to whitelist those. But then, basically backend APIs, making sure only authorized users with valid tokens can get to it. We start getting on-prem, doing things like mutual TLS. We're basically sending over a client credential to make sure that we're the client that it expects, and all the way down to our database. Those are all the red lines that you see on here. The other key piece of this is logging. And logging is very important because, again, if you assume breach, it's really important to know how much or where did they actually get to if you've actually been breached there. I don't know if you guys have gotten any of these letters. I've gotten a couple of them where they basically say, hey, we're not sure if somebody got your data. We don't think they did, but we don't really know for sure. And it's because they basically discovered that they had something open that wasn't supposed to be open, but they don't have any logging in place to know if somebody actually clicked on it or did it. So that's a really important thing to kind of keep in mind, is like you want to have that login, or you have to send out that email that says, well, they may have gotten everything, but we don't really know. The other part, no matter how many tools we put in place, we should always start with the developers and having our developers know what those secure coding practices are. OWASP and OWASP Top 10 is a great place to start. You can set up like lunch and learns from your teams, give them examples, start giving them the secure coding standards for code reviews. And a great place to start with that is this OWASP cheat sheets. And OWASP is basically a public group that what they're designed to do is really make sure websites are built in a secure way. So they have a lot of tools, and we'll talk about a couple more in just a little bit. But there's a cheat sheet for about every single platform that you can imagine. We've got for like .NET, Java, any of the languages in different platforms too. Like if you're building REST APIs, there's cheat sheets for that. And then over on the right, you can see OWASP comes out with a top 10 list of vulnerabilities every couple of years. And you can see, I'd say probably if security is kind of new, one of the things you've probably still heard of though is SQL injection attacks. Those are probably the most known types of web attacks that are out there. But if you look, see what still the number one vulnerability is, and those are still injections. Now they're grouping a couple other ones with it, but in general, they're the most commonly known, but still the most commonly vulnerable with the websites. So really having that in place is important. Identity is very important. So identity has really become the new firewall. So if you're building a system and you don't have to, don't store your username and passwords in databases. Leverage one of these third-party tools for doing that. Look at whether you're using like social accounts like Facebook or Google, or more enterprise ones like Azure AD, Okta, Identity Server. We'll let them do that instead of us trying to figure that out. The other thing is making sure we're using least privilege from an account perspective. And what's really important about that is that the least privilege, it basically means like everybody on here, it looks like there's about 33 people on right now. If I gave everybody domain access just to keep it easy, somebody trying to break into our site, all they have to do is get one of our passwords and then they would have full access. And really probably not everybody, maybe only one or two people on here need the domain access. So only give those users that. And then if you do, make sure if you have admin users, make sure you're securing it down with either two-factor or multi-factor authentication. Just a couple other quick things here is a couple of common vulnerabilities are man-in-the-middle attacks. And so if you've ever used like Fiddler to inspect your traffic and even unencrypt basically see the unencrypted data, you can do that because you own what's encrypting it. But out in the public, as long as you're using HTTPS, and it's hasn't been compromised, then you should be somebody in the middle wouldn't be able to see what you're actually sending. But if you're using just regular HTTP, somebody could be out there sniffing your traffic and stealing those things. So using like public Wi-Fi and things like that, you just need to be careful there. Cross-site script request forgery. So that's really where they can basically trick your browser into thinking it's on a website, and then the browser will hand over the authorization token or cookie, that will basically then give them the authorization to the website that they thought the user thought they were going to, and now all of a sudden those account has been compromised. So a lot of times we'll use authorization headers for this and access tokens instead of cookies, and that definitely seems to help. The last one here is the cross-site scripting. This is where, basically in your DOM, some JavaScript was injected that you weren't really expecting. Very simple. If you had a text box and there's somebody put in some JavaScript in there, if you don't encode that, then it will actually execute when that DOM refreshes if it's part of the DOM. So client-side scripting or client-side tools like Angular has that protection built in, but you still need to do those things on server side. So we'll show that here in just a minute. All right, so we've basically said now we've got this, we've got secure infrastructure in place. Our application is being built with some good secure patterns. But one of the things we want to do is validate that our application is still secure through our entire lifecycle. And that's what we can do is with continuous security validation. And that's where we'll probably spend most of the remaining time here talking about that. One of the things you'll see is when we're talking about the security validation is we're really trying to get that feedback back to the developer early into the process, because as we go through our machines out to dev, test, and prod, they get exponentially more expensive. Unfortunately, we all know what exponentially means now with growth. So you can see that basically going to those different environments, you can save a lot of money by doing it early in the process. So we're going to go through those steps here. The first couple of things we're going to look at are both things we can do from our development machine and from a CI perspective. And we talk about CI, that's really that kind of a gate that we can build our application before it actually gets committed. So there's a few. So one of the things that we can do is we can actually inspect our source code to see if we're actually doing things in an insecure way. So there's actually tools that will go look for patterns to see, okay, is there something the developer is doing that can be exploited? And there's a number of tools that are out there that can do that. So the first couple ones are some commercial tools like checkmarks and Veracode. So a lot of organizations are using those to help identify those. But there's also, if you're not using any tools, there's really no reason you can't add some of these open source tools to actually make things better. One of the ones I really like using is this security code scanner. It's an open source tool and free that you can basically add into Visual Studio. There's also tools like if you're doing Angular, React, Vue, depending on if you're using just JavaScript or TypeScript, there's security add-ons for some of the most common linting tools for like ESLint and TSLint. So a lot of options there. And then of course, different languages like checkmarks, I think can do like over 100 different languages. So a lot of options there to be seen. The other thing we can do is we can actually check to see what are open source vulnerabilities. So one of the things, even though we might be writing the most secure code in the world, if we're using third-party libraries, which about 90% of our applications out there are using, and I would say up to 50% of our code even sometimes can be those third-party libraries. If there's any vulnerability in those, that's where our application can still be at risk. And I'd say most of the time it's not those third-party libraries we're using directly. It's the third-party libraries that those libraries are calling into another library that's calling into another library that might have those vulnerabilities. So from a manual standpoint, that's almost impossible to help manage. So there's some tools out there that really can help do that. One of them we use, and what's really nice is White Source Bolt. It's actually a free tool that you can add into Azure DevOps, and I think there's a couple other tools you can actually add it in there too, but we use it in Azure DevOps. But that basically you can add into any of our builds, and then what we'll do is actually check to see, do we have any vulnerabilities? You can see here there's some there was a vulnerability in this that was causing it to break with this. So it's really nice. Like I said, this is a free tool that you can do. But there's also like a paid version of White Source that you can actually have more control over there. But just again, if you're just trying to get some stuff added, using that from a free standpoint gets you pretty far. All right, so let's take a look at one of the things we're talking about with the code scanner. All right, can you guys see Visual Studio? I just want to make sure that it is switching over there. Hopefully you guys see Visual Studio. So one of the things you'll see is this is an application called webgoat.net. It's actually an application that OWASP built that has a lot of vulnerabilities. I could have actually used one of my old applications I built that we'll just use one here that's not. So the first thing you'll see is I built it and I've got 65 warnings. What we're going to do is just very simply add a NuGet package. Here, this security code scan. Go ahead and add the latest. And then we'll go ahead and rebuild. You can see it's already starting to find some additional vulnerabilities. And now when we go look at the warnings, we'll see over 100. So we have definitely a lot of issues here. So let me move back all these. So you can see here we have cookie is missing a security flag, HTTPS only. Let's go ahead and double click on one of those. And you'll see, sure enough, I'm using a cookie here. And it's basically telling me that it's missing the secure flag. I don't really know what that means. So let's go ahead and click on this warning. And then what you'll see here is you'll see that it has a number, it actually has the solution on here. So you can see, okay, so we want to actually specify that our cookie is secure, and then that's only can be used. And the other one, if you noticed, was there's no HTTP only flag on there, that we could specify that for true. So as long as we don't need to access this in JavaScript, which we normally don't need to do from a security cookie standpoint, we can go ahead and mark this as true, so that'll encrypt it, and then we can mark it for HTTP only, so JavaScript essentially can't get to it. Now, one of the things, so that'll be really easy to add, so we'll add that here in just a second. But the other thing I just wanted to show real quick is here's a number of different things that can prevent. Injection attacks, SQL injection, cryptography, there's the cookie ones, view state, request validation, password management, so quite a few things for just a free tool. So let's go back over and take a look. So we can actually come down here, and in the next line, I can just say cookie secure. Oops. Equals true. I'll go ahead and just add the cookie HTTP only. True. Just switch back here. Yep, both of them need to be true. And then when I go off of here, now you can see the line is gone, and then you'll see this is automatically being updated. So now that there's only 102 warnings. So like anything, if we do this early on in the project, it's a lot easier to go back and fix them. But, you know, it didn't take very long. Wouldn't take very long to go through a lot of these. Let me just go ahead and show you one more. So here's a cross-site scripting vulnerability. And you can see that, again, we're basically now appending, you know, get password something here. So if there was something in this text box that is JavaScript, it's not going to render that, or it's not going to encode that, so it'll actually run the JavaScript, and that's really the issue. So again, I can click on the actual error message. I can come down here, and you can see, well, we just need to do something real simple like HTTP, HTML encode. So I can come here, I can code this hereafter. And now I've got another warning gone. So really just going through and identifying that to get all these warnings down. And again, just a free tool. You know, tools like checkmarks and things like that can do it also that are, you know, commercial. They'll actually show you, they're a lot more advanced and be able to show even harder things than that. So I just want to pause here real quick. Any questions at all? And, you know, really looking at things from a code standpoint. Okay, so, all right, so that's really the coding one. Again, just a real quick example. If you do have questions, feel free to put them out in the chat window. We're gonna keep going though. So the next thing we wanna do is look out. We wanna look now, so we've basically done some of that security validation before we've even committed that code into our like master branch and built our CI, but now that's all passed and we've packaged up our application, and now we're actually deploying it out to our environments. So we want to still make sure that there aren't any vulnerabilities once our application's been deployed, and there's a few things we can do there. The first one is one that we use, a tool called OWASP. So OWASP is a free pen testing tool that you can download and install, and basically it's used by both professionals all the way down to people that are just learning. But it's a great tool for doing pen tests and checking to see if there are vulnerabilities. And when we talk about that, that's really against, so the what we talked about with the source code, that's really where we can see inside the code. What we're talking about now is more what's called black box testing. Essentially, we've deployed the website, and we're going to hit the website from the same endpoints that users can, but we're going to do it in a way that's malicious to really test it to see if there are any vulnerabilities, so that we can test it to verify those things before somebody else does that has malicious intent. So we're going to use this tool called OWASP, and what we can do is use that, and shouldn't use an acronym here, but our software delivery pipeline. So that's really just our CD pipeline that we're talking about. But what we do is we're leveraging, so OWASP, you can both just download that tool and install it, or it actually comes in a Docker container, and the Docker container is what we've actually used this here in our tool. So what we can do is actually, once our application is deployed, we're going to run this pen test, or what's called a dynamic application security test, or DAST. And we're going to basically pull down the OWASP Zap Weekly container. So if has the latest and greatest fixes and controls there to be testing it with the latest. We'll start that container. We run a baseline test as part of our application pipeline. So it just takes a minute or two, and then we'll report back the results. Now we've built some integration with Azure DevOps that I'll talk about here in just a minute. But what it does is actually creates bugs for any security alert that it finds, and then it'll actually fail the release if there are any issues. If there's any high issues, it'll actually fail the release overall. And what's nice is we're using with the Docker container, we're in Azure, we're using container instances. So we basically spin up that container instance, run the test, get the results, and then just discard that container instance. So we only pay for it while the test is actually running. So it's very cost effective. So in addition to doing that as part of the applications pipeline, we still want to run a more thorough pen test, essentially, on those endpoints, because that only ran for a couple of minutes. A full pen test could take a couple hours. So we want to do that as part of our nightly pipeline. And one of the things we can do with that is we can actually run multiple endpoints against it. So one of the things I mentioned earlier was using a web application firewall. But the job of a web application firewall is to actually block malicious attacks. So if I'm using OWASP Zap against the WAF should do its job and not let me in. And that's a really good thing to validate, because we want to make sure that that front door is actually doing its job. But we also want to still make sure our code is secure, because for some reason, if the WAF failed us, we would still want to know, are there vulnerabilities in our code that the WAF is essentially protecting us from there. So you see here, a lot of times what we'll do is we'll actually run it with the WAF, and then we'll run it through like a private endpoint without the WAF. And what that does is that allows us to find bugs, if there's any through the WAF, but also behind the WAF. So there's those things that the developer can fix. I mentioned there's the integration. So what that looks like, and I'll show you a demo here in just a minute of what that looks like, is it's part of our release pipelines. And what we do is it actually comes across as failed tests. And then, like I mentioned, any of those failed tests also get created as bugs. And one of the nice things too is if it gives traceability back for the development team to know what to fix, and then to show that they actually fix these security issues. You can actually mark them resolved, and then the next time the pen test runs, it'll close those bugs automatically if they've been fixed, or if they haven't, it'll move them back to active. So that's one of the nice features of that. I didn't have it listed on here, but this integration is something that we actually have out of GitHub. So if you want to, and I'll put the link, I think I do have the links at the end, but it's just github.com/Deliveron, and then it's pretty obvious which repo it is that has this solution in there, but so that's something we've put together. The other thing, so once we've deployed our application and made sure that's secure, we also want to make sure that our infrastructure is secure. So if you are deploying to Azure for your applications, there is a nice toolkit that Microsoft's created called the Secure DevOps Kit. And what that'll actually do is that'll actually validate the infrastructure that your application's running under. If you're using an ARM template to actually do like infrastructure as code, you can verify that template before it even gets deployed. You can't verify everything, but it can find some things. But then once you deploy, you can actually go and run the verification tests, and you can see it basically turns all the Azure Security Center tests or checks into tests. And so it'll go through and verify a bunch of this. This is a production web. No, I'm just kidding. This is just a test one I deployed. As you can see, app demo. So definitely a lot of these security vulnerabilities out there with this one here. But you can see 29% passing. So that's a really good way to show, that our application is secure. So you can create custom rules. You can also, if you want to ignore rules and things like that, you can do it too. So a lot of flexibility with this tool. But it's just if you search for a secure DevOps kit, it's a free tool from Microsoft. One other thing that we built was this validation. One of the things that, even though we have all these tools in place, one thing that it doesn't know is it doesn't know the intent. So like if I'm a developer and I deploy something public, did I mess up or should it be public? And this is a tool that we built that basically goes through a list of whitelisted things, whitelisted endpoints, and then we'll scan Azure to see, is there anything outside of that list that's still public? And then it will actually generate an alert and send that out so we know something's failed. All right, so now let's show here a couple of things. We're cruising right along. So we're going to go and now look at the Azure DevOps pipeline to show both the CI side of it and the release. Okay, so here we're in Azure DevOps, and you can see I'm in this ng6 users API repository. This repository, I'm also doing this development branch here with all my changes. And one of the key things that we'll do when our changes are ready to be pushed is we'll create a new pull request. Hopefully this part most everybody's seen. But here I'm basically now putting my changes into the master. And then once we have that pull request, here's kind of our first defense of making sure our application is secure. So the first thing that's going to require is it's require somebody to do a code review. And again, if we have those security checklists, we can actually have somebody verify that in this code, nobody's added anything that's insecure. Obviously, we don't want to depend on that, but that's definitely one line of defense. The other thing is the build is actually kicked off. This build will have to succeed. This build includes compiling our unit tests, but it also includes that white source bolt, and then also any of those security rules. So if any of those fail, this build will fail, and that will prevent this code from making it into our master branch. So that's a really great way to show how we can protect that. So let me go here to pipelines. You can see here's where that PR build's kicked off. We'll just look at one that ran here. And then you can see, oops, that's not what I want to show. The summary that it's been built. And then we have vulnerabilities. Wow, this is brand new actually. So there's definitely some new vulnerabilities here that are being caught. So you can see a number of these here. What's nice about this too is there's usually the remediation steps to actually being able to fix it. So you can see here, one of the things is to upgrade it to 4.3, and then that will help resolve that. So you can see 17 issues with that, and we can get 9 highs. So much more exciting demo to show when we actually have failing things in it. Any questions? Let me look real quick on here. All right, so we mentioned kind of equivalent for AWS to the Azure Security Kit. That's awesome. And yeah, Micro Focus. Yep, definitely they're another one that has a lot of tools in this space too. So definitely a lot of tools out there that can help. All right, so here's kind of the build side of it. Now once we have, if this were to pass and we get our application out there, we'd be able to actually kick off our release. So in Azure DevOps, things are broken into 2 parts: the pipeline for CI/CD, and then releases for the pipelines that kind of be our software delivery pipeline to go through all of our environments here. So one of the things you can look at is I've got one of my releases here that's ready to go and just waiting for a prod approval. But in this case, I want to look at my latest release. But before I do that, let's actually go and look at what it's doing here. So this is what our pipeline looks like. We have our artifacts that we're going to be using from this. You can see one of them is the OWASP tools. We see we're basically deploying from dev to test to production. with that approval step that we saw here before things can go into production. From a security standpoint, though, here's kind of what our pipeline looks like. Where the first two tasks here are basically deploying the infrastructure, so doing our ARM templates out to provision our infrastructure. The next two are actually deploying our latest app changes. So we're deploying the API in our web as part of this pipeline. And then the next three steps are basically what we're doing from an OWASP app standpoint. So we're running this baseline pen test that will go and basically spin up the Azure container instance, pull down that OWASP app container, and run the test. It actually mounts a storage account, and then we'll basically copy and then save off the report, XML report, and a HTML report that we can then use later to basically one, attach the report, and then two, create any bugs that we might actually see from this. And then the last thing is, if we want to run some functional tests here, we can do that. And then here is those security verification tests that we can actually execute for each of those steps. So pretty straightforward. Most of these steps are just essentially calling, like here is, it's calling the invoke OWASP app ACI baseline tests there. These are running a few verifications. And then you'll see here like this Azure security, or the secure kit is basically just pointed to a particular resource group and then looking at everything that was deployed to that. So what that looks like then from an end result is we can come in here and actually look at our failed, or at our deployment to dev. Oops. Here into the logs, I can actually come in here to the tests, and you can see here were the OWASP ZAP test results. This might not mean anything to me, so what I can do is actually click on here, look under the attachments, and you can see there's the report that it generated. And so I can click on that, and this is what the developers can use to really identify what those vulnerabilities are. And you can see here overall, there's 1 medium, 6 low, and 2 informational. So that's why this allowed this to go through. There's just those. What's really nice about this is this, again, will help talk about like what the remediation is. This is not language specific though, but it is pretty easy. I've not had any trouble either relating this to like .NET or to another language. It's pretty straightforward to do that. And then you can see there's some low ones here. So again, a really nice way to basically bring in that OWASP app piece. Any questions on that? All right, I think there's a slight delay, but I'll keep going. Definitely feel free to answer any questions there. So again, this is basically how we can get that incorporated in there. And then at this point, we've essentially validated that all of our tests are there. If we go back and look at our tasks, we go back and look here, you can see everything passed up until our security verification tests. And you can see we have a number of those failed tests here. And then just like what we saw, we can see the number of passed controls, the number of failed ones, and the percentage. So I'm doing a little bit better than my screenshot was here, up to 34%. But still, obviously want to try to get these to passing. But you can see here like which ones are failing, which ones are passing. Again, not all of these, just like any static code analysis thing, errors, not all of them will be applicable. We can actually come in here and disable some if we need to. All right. So that's our pipeline. So that's really that continuous security validation, how we can do a number of checks to make sure application is actually being validated. All right, so the last piece of it is monitoring. And the reason I want to talk about monitoring is because even though we might not be making changes to our application anymore that would go through that continuous security validation, you can guarantee that the people trying to hack our website and to breach us are changing their attack methodologies all the time. So really that means that security, even if we're not changing, is a living and breathing thing. The other thing you want to do is really assume breach. And what that means is, when we talk about that layered security approach, assume somebody gets through that front door. What did they get to? What can they get to from there? If they get through the second door, what can they get? What can we get, from there? And then how can we know that somebody is behind that got through, and actually, how do they know, and how can we actually like kick them out of the site? Sometimes we just have to turn the site off if they're detecting somebody's getting in, or we have to recycle it, or we have to disable all of our valid tokens that we might have out there. But you really want to identify that at the beginning, so you can have those steps in case those types of security things happen. And that's something we try to identify in like a sprint zero. We'll just kind of do that security. That's basically that layered security documentation to make sure that, and can have that plan for detection, prevention, and remediation. Again, one other thing too, from a monitoring standpoint, that we typically do is, or basically if this is required, we may need to put in something like an audit service. So if we have, as part of our security is making sure that what goes out of our pipeline is what's supposed to, we can actually create some hooks into our pipelines to really verify that a developer or somebody hasn't changed something that shouldn't have changed it. One of the downsides with Azure DevOps is you either can make it read only, or you give basically rights to everything from the kind of the classic editor in that. And one of the challenges with that is you don't want somebody to change like who can approve a PO. We don't want to have somebody going and changing tasks and things like that. So a tool like with like what we've built before for like audit services, we can actually go and verify that the pipeline still has all of our compliance controls that we need. So we can verify things like all the automated tests passed and ran, or somebody tried to disable those and try to maybe cut corners because they want to get something out the door. This will detect it and essentially fail that release instantly. So the next thing we want to look at is from a monitoring standpoint, how things can actually, we can leverage like machine learning with a number of tools. One that we use quite often is App Insights in Azure. There's a number of them, another number of other tools that have similar capabilities. But one of the hardest things to do is really when somebody gets into your site, if they were to compromise somebody's username and password, they've essentially broken through that first line of defense. And it is hard to know, is it a legitimate user, or is it somebody that's in there trying to hack our site? Typically, there would be some anomaly though with that user and how they're using it. A lot of times they'll use something like brute force to try to get to certain things. And where basically things like App Insights can actually detect different or changes of usage of your application. So it'll actually alert you and say, hey, somebody's doing something totally different than they've ever done, or doing it from a location that's ever been done. So there's a lot of ways that can help really drive that. The other thing from an Azure perspective is Azure Security Center, and this will give you warnings of everything across the board that you've configured from an Azure perspective to know, have you done it a secure way, and even ties it back to particular regulatory compliances that you might want to select. And then it'll tell you if you've actually configured it, or resources you're using are actually fall within that compliance or not. And then the last thing here is talking about Azure Sentinel. So basically now Azure has a full SIEM in there. Basically it's a security tool that gives you a single pane of glass to go across all your logging to really help identify there. There's a lot of really good SIEM tools. This is fairly new that Microsoft's put out there, but a tool like any SIEM tool can give you that ability to detect detect if somebody's actually compromised your site and what to do about it. All right, so I think we're about to the end here with some winners that we want to pick. So we've got 31 people online now. Let's see, there's a couple of questions. Looks like Clyde here has a couple of questions. Micro Focus, from a monitoring perspective, are you also going to address how an issue or suspected issue generated at a ticket and how the whole process works? So I wasn't going to really cover that piece of it. It's really more from, I'd say more from the development perspective of really making sure things are getting protected or getting detected before they get to production. Obviously, I covered a few monitoring things, but probably a little bit more from the developer perspective. But yeah, I think the big thing there, like you mentioned, is you don't want to generate tickets for false positives. I'd say that's probably the number one challenge of any of these tools is trying to narrow down the noise of some of the false positives that they can create. For the integration we built with Azure DevOps, one of the things you can do is actually identify false positives and then basically have those not show up the next time. So that's definitely something we'd want to have that control. And then somebody's asked if the slides will be available. Yeah, so the recording will be live here in just a few minutes. So we'll be able to go back to it from a YouTube perspective. But yeah, I will put the slides out on our DevOps Meetup site. Let's see. Skylar asks, when you do a pen test, are you doing authenticated tests or is it just an IP external test? Yeah, that's a great question. So we do both. So we definitely want to, a lot of times if we're just doing just a straight spider of the site, it's not going to know like our particular URLs. A lot of times we'll generate some of those. We can basically generate what those actual authenticated requests and users are and basically bring that in, and then it'll actually be able to detect past the login screen. So yeah, it's a really important piece too, Scott, that you want to validate after that. A lot of times we'll kind of train it, if you will, to know what those valid URLs are and to be able to log in and authenticate. Any other questions? All right, so we're to everybody's favorite part here. And we're ready to draw some winners. So let me switch back here. I found a really fancy tool here to generate our winners here. And so we got, somebody just dropped. So let me see if I can, what I wanted to do is get a list of all the users. Appreciate all the thanks here, but try to hold on 1 second. I'm just trying to get, here we go, participants. Yeah, it's showing 28 people on, so I'm trying to figure out the best way here to actually show the list. Second, if I just show the participants, it only shows like 8 people. I know there's more than that on here. So let me figure out the best way. Back to 29 people. See if people want their there. All right, so what we're going to do, I'm going to go through this list, and we'll go through, we'll validate between 1 and 28, it looks like are on here. So I'm going to go ahead and get a random number, and then I'm going to go down the list to see what number it actually picked, and then that'll be the person there. So first number is 16. I was hoping it was going to be a short number so I don't have to count as far. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and Kevin Lane. Kevin, are you still on? You do have to be present. Kevin, are you still on? Kevin Lane? All right, we'll pick our second winner here, and we'll see if he comes on and says he's still here. 8. All right, much shorter number. And 8 is, I'm not even going to try to pronounce the name. Are you there? Apologize for not even looks like you were just on there. I don't know if that's usual. But please let me know if you're still on and you won one of the $50. Yep, I see. I saw him. Skylar just comment, so we'll assume he's on. But I don't see Kevin. Doesn't seem to be like he's on anymore. So we will try one more. $17. Definitely gonna have to come up with a better way to do this. All right, and try Will and names. There you go. Actually, we have you actually were chosen for the second one or first one, technically. All right. All right. Uj or UJ? You guys are my two winners. Great. Well, congratulations, guys. Reach out to me on the DevOps Meetup chat, and I will get you the information for your gift cards. So, any other questions? Yep, you won. Yep, congrats guys. Thanks again, Dynamo and Deliveron, for being our sponsors today. And I guess if there's no other questions, I look forward to talking to you guys here in a few weeks. Everybody stay safe in their homes, and we'll talk to you soon.